Okay, I think I am live. Hey, check. I was supposed to have a guest today, but I don't know what's going on with him, so don't have that guest right now. But doesn't matter. We're live. It's been a long time because I have been traveling everywhere on the planet. I still have a couple weeks of training ahead of me. Got training after this week and some training next week. And then I'm taking off some time, though maybe I'll do a show or two if I'm feeling like it. But it's nice to sort of be back. I was in Austria a couple weeks ago and Indiana, and which is cool, right? Like everything's cool. So yeah, I'm going to show you some cool stuff that I've been working on kind of nonstop. But it's in a really, really good place now. And I think it'll be fun to sort of hack on that and then also show you sort of what the next step is for me. I do have to fix some examples, but I think when you see the examples and where I'm going, you should be sort of excited. All right, let's just get going. And then if Chetan shows up, we'll switch gears because I wanted Chetan to show off a project that he's working on. Maybe some content for the monosynaptic folks in the crowd. Kevin is not feeling well, so he's not on. There is some sort of thing going around. I don't know what monosemantic means. I gotta look that up now. Monosynaptic. What is mono? Meaning a single. I have no idea what you mean, but anyway. I had to look that up. So Kevin won't be with us. Oh, wait. Looks like Chetan is here. This is perfect. Hold on here. Chetan, we're live. We're live, but I got to figure out how to add you in here. So hold on here. Okay, I got you on this screen. That's good.
It says Kevin. I think the names are.
Yeah, it's going to say Kevin because Kevin's normally on the show with me on this screen. So that's fine. But I got to get you on this screen, which is where we're going to spend most of our time. So hold on. I think I can get you there. That's even better. Okay. So this is perfect. I got you here. Perfect. Okay.
Awesome.
So let me see. And that's my screen right there. You should be able to, oh yeah, how do we do that? You should be able to share yours. I might need Kevin. Kevin's watching. You should be able to share your screen. And I think I can.
Yes, I can share. I do see my ability to share. Give me 1 second. I'm going to knock off the. Yep.
I'll figure out how to get it in here too.
Okay. Screen sharing failed. So I'd say.
The screen sharing failed, huh?
I'm trying now. Can you see my screen?
Yeah, I see it. Okay. Sweet. Now the question is, solo with pip.
But the main screen still shows your screen.
Yeah. No,
what I see.
I see your
Okay,
screen. I just got to figure out now how to place that in an overlay. So hold on a second. Maybe I can change. I'm gonna have to call Kevin up because this is always tricky. But I see it, so that's a good thing. Hold on. Here it is. All right, hold on. Let me just call Kevin real quick. Oh, wait. Is there a guest code screen? I don't think. Oh, there. Wait. Let me see. I see. Kevin, I do see a guest code screen in my little thingamajig. Let's see here. Camera switcher. Does everybody see that little window?
Why are you crying?
Let me see.
Why are you crying? What?
Oh no, that's me. Hold on. Oh, did I just screw up? Okay, hold on. We're gonna get there. I promise. This is why
Take your time. No
I said
worries.
screen default. You need to go there. Hold on. Screen scene. Hold on. Kevin, give me a call, dude, because I ain't gonna screen default show. We're gonna get this. I just never. Kevin's always here, so he just does all this for me. Okay, Kevin's on the phone. All right, dude. What do I got to do, Brandon?
Okay, so you need to. One way to do it. It's hard without seeing. Here, let me FaceTime you instead. Let me FaceTime you.
All right, got Kevin here.
Okay, show me your screen here.
So I could edit.
Can't really see it.
Oh, what is that? Here, let me reverse this thing. Hold on. Why is this so hard to reverse from? Oh, no, that was bad. Oh, here it is. Okay, here.
Okay, cool. So show me that top drop down, top left, the gray up there. Yep. Default scene, screen share, cover. Okay, show scenes window. Click that. Perfect. Now hit the second screen share one. Hit the little play button, like the.
I got you here. I got you here. Uh-oh. What just happened? Sorry, dude. That just went away. Let me try again.
No worries.
It's
Take your
so
time.
frustrating. I don't even remember what I just did.
You drag and dropped, I think, from one of the screens, if I remember.
Okay, I'm now unmuted. Can you hear me?
Yeah, all good, all good.
What
There's a
the
little
heck?
delay.
What
Yeah,
the
you're
heck
good.
is going on, bro? Okay, Chatton, can you hear me now?
Yes, I can hear you crystal clear.
Man, I'm having so many technical problems. Okay, you
No
can hear
worries.
me. I I can hear you. And then the person that's on the line, is there still an echo when we're talking? Because I can just mute and get my headset. Or Kevin, is there an echo?
Just no echo, crystal clear, at least from my side.
Okay. So I'm still going to get my headset, but why don't you start while I go get my headset? Start explaining to everybody, the TLDR on what you've built here, and then we'll figure out how we can hack on it. Because I have some ideas, but
Awesome.
why don't you start that? I'm going to run and get my headset.
So, couple of things. I'm just going to scroll. I want to make sure everyone sees my scroll. Is that working as I scroll my screen?
Yeah, I see it.
Do you think? Okay, excellent. That's awesome. So, hi, folks. Looks like 10 members have joined or 10 viewers have joined. I'm very quickly going to introduce myself. My name is Chetan Konaki. I was most recently the CTO and founder of an application security company called as Quiet, QWIET. We were recently acquired into Harness, which is a very famous and popular company in the CI/CD realm. And what I'm going to talk to you about is something that I'm going to be launching in the next few days. So what you're going to literally see is an early draft of everything, that's coming together and tying together for this launch that might happen in the next few weeks. It's a very interesting project. It started mostly with the impetus to scratch my own itch. I faced a set of problems like all of us entrepreneurs do. We go into exploration to figure out how to solve the problem. And this tool was born as a consequence of that. And I'm going to talk to you folks about that in somewhat of great detail, but we'll make it a fun journey through the process.
Well, all I'm going to say is I think when I got a demo of this already, and I was sort of completely blown away by what you built. And I'm been living in this space for about 18 months. So I really appreciated what you built. So I want you to go through this, and then I want to show you a little project, and maybe we can hack Dex into it in some form. I think it would be super interesting.
Awesome. Excellent. So I want to set the stage. First of all, thank you, Bill, for having me. It's always exciting to present with Bill because he sets a high bar, which means that I have to figure out a way to either go higher or level up to him, because I've greatly admired how he runs his workshops, how he communicates, which is why he's earned this respect in the Go community. So thank you, Bill. Thank you for having me.
Appreciate that.
So let's get started, right? I presume all of you are aware of MCP, or what they call as the Model Context Protocol. MCP was invented, or the protocol was defined by Anthropic not too long ago. It came out to serve a particular need within Anthropic. And we'll walk through to understand what that need was. And from there on, I'll explain why I got interested with MCP and why I built Dex. The name of the tool is Dex. So let's start with how the world operated pre-AI, pre-agentic, pre-generative AI. All of us as developers hosted services in private data centers and cloud. These services served specific domains. For example, if you're dealing with Stripe, it's finance. If you're dealing with Slack, it's social communication. If you're dealing with any service that serves your needs, of course, you as a developer were provided APIs, because typically the modalities with which we interact is either through a browser or through an API. An API gives us this accelerated flexibility of hooking up or integrating with that service, and then taking data from that service and then connecting it, correlating it with other services. So pre-AI, on the left-hand orientation, you have developers in the RPC, or these bevy of protocols with these many, many APIs. And when the API standard exploded, as you see, where you have REST, GraphQL, gRPC, OpenAPI, SOAP, Google Discovery, developers had to figure out how to interact with these systems through a schema that was provided by these variety of vendors. And each of these vendors had, a certain reason, justifiable reason why they didn't prescribe to a single API. For example, Google chose Discovery because they have their own set of suites or services like Google Docs, Gmail, Calendar, Spreadsheet. Each of these services worked with in a stateless mode or in a stateful mode or potentially in streaming mode as well. So by defining these standards, they provided developers with the ability to effectively communicate with their services. So we as humans read the schema, built our services, and these services served our business or our needs. Not to say that the ecosystem sorts of fragmented because of this use, but we sorts of acclimated to that fragmentation. Now, what I call as Act 3 is transformers. This fundamental thing just came as a wave and created, I would say the most fundamental innovation that we have noticed over the past maybe couple of decades. And with transformers, lots of additive value was built around transformers, like agents which scaffolded the transformers, took over the observe react paradigm, which is, typically when you're dealing with transformers in the early era, we were chatting with those transformers through a chat interface because OpenAI defined the notion of tokens, our ability to communicate with these transformers, elicit our requests or what they call as inference, and then get answers, which was amazing, was extraordinary at that point. But of course, we wanted to extend the value of transformers, where we wanted to put that in a loop, to schedule that, to give us the ability to communicate with other systems. So agents were born. Agents have, it's very hard for me to define agents because I can't be true to the fact by saying that I don't really know the definition. I don't want to disservice the definition of agents by taking a marketing stab at it. But loosely put, agents are scaffolds over transformers, or what they call as large language models. What agents provide is the ability to understand the elicitation, or if a user asks a question or infers their intent, the agent takes that intent and serves it to the model and gets back a response. Most likely the response might be right or wrong. So what the agent needs to do is figure out through goal-oriented strategy or reward-oriented strategy of what is the right answer for the user, and then continue that loop and then serve that appropriate answer to the user. This often is called as alignment, but short definition, the agent brings intelligence or additional intelligence to the scaffolded large language model. Besides that, the agent has the ability to use tools or evoke tools to communicate with the rest of the world. As we all know, the rest of the world are a bevy of services that we just spoke of, like REST, SOAP, GraphQL, gRPC, and maybe in the future it's going to be a thermostat through Zigbee protocol or many other variety of protocols. So when that fundamental shift happened, you could imagine that there's not just one tool. There's several double-digit millions of tools that the agent has to get familiar with to effectively communicate through the large language model. That would mean it's just not the permutation and combination of tools. Tools could be a Git that is installed on your computer or a curl that is installed on your computer to all these APIs like REST and SOAP and gRPC and GraphQL, which are endpoints, several thousands and millions of endpoints. And node training means familiarity, which is if these large language models are pre-trained, they're observing, corpus of data that they've accrued through Stack Overflow, various communications on other channels, establish some sort of standard of how to communicate with these services. So pre-training became a burden because you can imagine there are several millions of such tools, both command line tools and endpoints. And the agent needs to understand not just how to communicate, but also what is the sequence of communication and what is the order of parameters that are needed for this communication. For example, Git in itself has several commands, several flags, several parameters. And the more the familiar the agent is, or the large language model is by virtue of pre-training, the more effective the communication is. So because of this, pre-training became an expensive affair. And as a consequence, most of these frontier model companies like OpenAI, Anthropic, Google with Gemini, Meta had to spend several millions of dollars and time and compute to conduct this pre-training to ensure that, there is a degree of accuracy, there's a lack of confabulation or hallucination when these communications play out. And of course, through that journey, as a consequence of this journey, many adjacent possible technologies happen, like retrieval augmented generation, effective tool use, effective computer use. These are mere side effects that, if there's a cutoff in the pre-training, if you have a new version of curl deployed or a new endpoint deployed, how do you make sure that your communication is effective? So as a consequence of these burdens that they had to take on, model context protocol came to be, which is, can we figure out a way so that agents can communicate through a standard, irrespective of these bevy of services using many of these permutations and combinations of protocols? So MCP, as you know, uh, is Model Context Protocol. It's fairly simple. It's a very well-defined, I would say, language protocol. I wouldn't call it as a network protocol or any other paradigm as such, but it's an effective way of ensuring that whatever happens on the right-hand side, which is combinations of GitHub, Slack, Gmail using REST, OpenAPI, gRPC, or any of these other tool chains, follow a certain standard when agents communicate or touch these systems. So when MCP was defined, as you know, before I head there, if I have to very quickly abbreviate what MCP is it defines tools, resources, and prompts, and defines a state machine of how to communicate to these tools. Meaning, when I use the word state machine, think of it as a sequence where first the agent negotiates with the end service by saying initialize, where it acquires certain protocol information, version information. After that, it invokes tools list, which lists the set of tools that are available to communicate with. For example, when we're dealing with Git, the tools could be list issues, list orgs, commit, create issue, etc. And then you have resources and prompts. Resources are things that you can read. Prompts are instructions of how to effectively communicate with these endpoints. So when MCP came to be, many intelligent developers, many of the community members understood its intrinsic value. And as a consequence, there was a gold rush. As we know, when something becomes a standard, the economic model is to start creating value in the adjacents of the standard. So as a consequence, in the first draft, we saw many, many, many MCP servers deployed because a standard was defined. And with that virtue of a standard, you stand up a endpoint via Python, via TypeScript, Rust, or Go, or many of these languages. And these endpoints are listening and adhering to those negotiation protocols, like I described. So as a consequence, the first act was many Python servers emerged. And of course, herding these servers, managing them is somewhat, erroneous. So you have many companies that emerge saying, hey, here's a push button. We're going to host your MCP servers for you. And then on the adjacents, you have many other vendors saying, besides hosting, we got to provide security measures. So let's create MCP gateways. And gateways are like proxies, synonymous to, typical, I would say HTTP gateways. They provided security related value and also, typical adjacent values like rate limiting, the ability to drain if you have maybe an endpoint that can't deal with, the barrage of requests initiated. And then another problem emerged where if for GitHub, for example, there are 1,000 tools, right? And as models negotiate with via MCP with the endpoint, the second request is tools list. So imagine these 1,000 tools with their schemas are absorbed and placed into the context window. And that's a lot of information because, context window is like a RAM or in the world of large language models. Context windows where all of the information related to your context sits. And there is a concept called as attention mechanism, where you have many attention heads that are perceiving that context, identifying the relationship between tokens to give you the appropriate answer. So those problems arose. Lots of tools sitting in the context, then leaving you with little, like 2 or 3% to ask questions, which became a non-starter. So many other companies emerged building tool catalogs, putting these tools behind maybe a BM25 or what they call as best match or inverted indexes so that you can search for the tools, progressively reveal them, and so on and so forth. So net, you have 300 million deployed in many startups doing all of these businesses. And of course, many of these larger companies now are building MCP gateways in addition to their existing firewalls that they're providing. So my first encounter before I started building this was when I was at Quiet, one of our customers essentially asked, hey, can you MCPify your service? Because we want to use your service to communicate through MCP via an agent with ServiceNow, because we were in the business of vulnerability detection. And via vulnerability detection, they wanted to extract critical vulnerabilities and then create tickets or service tickets. And the easy part was, standing up an MCP server. That was relatively easy because everything was standardized. It took me less than 5 days to build an MCP endpoint, host that, worked great. And then progressively, as their agent using a frontier model like Sonnet or their own composer or their own hosted model on Bedrock, progressively over time, when they start hooked up 5 to 6 such MCP servers, they were hitting context window thresholds, which is the context window was getting thresholded with too many tools. As more and more MCP servers compounded, these tools and their schemas were occupying the context window. And when it started thresholding, then typically what a large language model does is it begins to summarize this context window. And summarization means it'll try to reduce the information fidelity and make space so that any other documents you add, any other questions you had, can go and sit inside the context window and make itself available to the attention head. Now, when summarization happens, the signal is lost. When the signal is lost, it leads to what is typically termed in the large language model as hallucination, where you ask something, you get somewhat of an obtuse answer. Your answer is misaligned with your question. And that's where you as a consumer gets frustrated because, there are no guarantees, there's non-determinism, and then everything falls apart. So this is how it kind of looks like. Your context window gets overloaded. You get a message saying, hey, I'm going to summarize and start the context window again. And it leads to a degree of like a loop, a frustrative loop. And The other issue that I also noticed is agents have amnesia. They do not have recollection of what they accomplished in the past so that they can reflect and apply that if the same request comes in the future. When our customer was asking the same question, fetch and prioritize vulnerabilities, it almost went into the same discovery process, saying, okay, I'm going to start MCP. I'll fetch the tools. I'm going to figure out what the APIs are. Then I'll apply the filters. I'll do the thing. So what the customer started doing is adjusting the prompts. Of course, in the world of large language models and agents, the hammer is always the prompt. And that is an excellent way of steering the agent to do the right thing. But prompts are brittle. There is no guarantee that if you have a particular prompt defined and optimized, and you switch the model or you switch the agent, that prompt will work. That's the nature of the brittleness of the prompt. The other issue is when you define a prompt, the prompt becomes tokens. The tokens goes and occupies the context window. And again, if the context window starts exceeding 70 to 75th percentile of the its threshold, no matter how effectively you steer, you are still going to get confabulated answers or misaligned answers. This is something that we saw up front. So in summary, the issue is agents have amnesia. You might define prompts effectively and you still hit that roadblock where you get misaligned answers. And then the industry or the community went back to the whiteboard figuring out, is there an effective way to do this where we do not want to burden humans with dealing with prompts? So the two innovations that happened, one is what they call as reinforcement learning, where rewards and goals were defined by the agent through what they call as React loops to figure out alignment and to ensure you get your right answer. The other very compelling innovation happened is a DPO, or what they call as dynamic prompt optimization. If you just Google on GEPA with dynamic or DPO, you will get tons of papers, excellent innovation, very, very interesting way of asking the system to dynamically optimize the prompt to ensure alignment. So these innovations are playing out as we speak. But for me, I was running against time. I was like, is there a more effective way to do this? More effective way to bring determinism to things that we repeatedly do. We are, as humans, we tend to repeat ourselves. Every morning we wake up, we read our emails, check our Slack messages, check maybe high severity issues in our system, any failures, catastrophic failures in our environment. So these repetitions shouldn't warrant discovery and exploration. It should be as such that the agent should instantly wake up, know what to repeat, know what to execute. So the epiphany for me was, can I make or endow these agents with some degree of intelligence? And my other challenge and criteria was, I do not want to use prompts. I do not want to use prompts as a hammer. I wanted to lend some of my past experiences because I spent a decade building protocols in the past, financial protocols. I spent some time building compilers, first pass compilers to compile code, to build graphs, to understand security and vulnerable paths. So I wanted to borrow some of that past experiences and ask myself, is there a way where I can build a language over MCP so that agents can negotiate effectively? And when this exploration happens, because agents are really good when they're guided with the large language model that they're using as scaffolds, where it goes through this exploration, always figures out the right thing to do. Can I capture these traces? Because these traces are very useful. Often they're tossed. Can I capture these traces in real time as the communication plays out during exploration and crystallize that as a skill? And my inspiration to build that was how we humans operate, how we humans solve problems. If I have to take you back to how you learned how to ride a bicycle, the first time you had no concept of a balance. You sat on that cycle, you oriented yourself, you understood how to hold the handle, how to maneuver from a direction standpoint, how to use your brakes when you have to, and how to pedal. And the first 2 or 3 times, you would have fallen multiple times. You had lost your balance. You hadn't effectively pedaled. But at some point, you started gliding. And when you glide, subsequently, you realize that that practice became a skill. And now, when you sit on a bike, you're not giving any attention to how to place your leg on those pedals, how to maneuver, how to handle your brakes. It's just a skill. Your brain short circuits and you effectively it's become procedural memory is what they call it. Note there's a stark difference between memory and skill. Memory is episodic. If I take you back to your birthday, you remember all the people you met and what happened. That is episodic. But procedure is a skill. A surgeon knows how to conduct a surgery. You know how to program because it's become rote memory. So that was my inspiration, where I asked myself, is there a way for me to capture exploration, convert that to a skill, compile and crystallize that, and place it in an index so that if a same question is asked again, I invoke that skill and completely sidestep or bypass that expensive tokenization within the context window. So Dex was born as a consequence. I figured out this is an excellent opportunity to bring what I call as determinism in the world of interacting via agents with extraneous services like we described through MCP. So after that, I asked myself another question saying, okay, I built this thing. Should I make it another agent? And if I make it another agent, then if I release it, then I have to convince the whole world that this agent has memory. And by the way, memory is not a skill. By the way, this brings degree of determinism. So I felt I don't want to be another agent because, this tool is effective enough to provide value to any agent that sits on the top using a large language model to communicate with any other service sitting on the other side, albeit what kind of protocol that the agent communicates with, like REST, gRPC, OpenAPI, etc. So I started implementing Dex using a simple CLI interface because I was inspired by Git, curl, JQ, awk, sed, grep, because these are the tools that have essentially aged over time. And they become better and they become fundamental units of our operating system. If you look at any agent today, they reach out to these tools still to solve your problem. Why? Because they've been pre-trained on these tools, and these tools are very, very effective because of the excellent community behind it and the tireless effort put by these developers who have put it out in the community. So my inspiration was that, and I asked myself, can I take the best parts of Git, awk, sed, grep, JQ, curl, and build a tool by first principles? I call that Dex. It took me a few months. Command by command, I built this. And, it's kind of gratifying because I've been using it for the past 2 months, literally for anything that I do through agents. So at the moment, to summarize, Dex is a simple command, just like Git. You curl install it. I'm going to give it away for free. And agents can be trained to use Dex in literally less than 20 seconds because agents which are scaffolded with large language models can reason by analogy. If I prompt or teach the agent to say, hey, Dex is like Git, like curl, like JQ or awk and sed, it very quickly acclimates to using the tool and begins to use it very effectively. The other thing I asked myself is, we already have a bevy of services like Stripe APIs, GitHub APIs, 11 Labs, and all these companies have open API specification that they've already defined effectively and spent years optimizing. So isn't it wasteful to, again, provision another MCP server that acts as a proxy to these services? Because, of course, if you're building an MCP server by first principles, where you're going to stand up a new service, that's great. But what if you have an existing API? And if you try to actually poll the most popular MCP servers, they're all proxies to existing API sets. So net, it's an unnecessary hop, where if you provision an MCP server, host it somewhere, and you're paying a vendor to invoke these tools through the MCP server, in my opinion, that is additional tariff. So what I'm going to do with Dex is give away a concept called as adapters, where in less than 10 seconds, you point to an existing open API or REST specification. It creates an on-the-wire adaptation of an MCP representation of that specification. When it does, in less than 10 seconds, you have an adapter for that API. And now you can seamlessly communicate with your agent. And by the way, you don't have to pay a toll fee anymore. You don't need that extra hop, a necessary extra hop through a gateway or through a tool. So this is Dex in a nutshell. I'm going to quickly switch and give you a demo. But in the meantime, if you have any questions, Bill, if you want to moderate any questions, given that I moved too fast, I'm happy to take them before I make the switch.
Yep. Right now, I don't see any questions, so that's fine. But that was a great presentation, man. That was incredibly detailed. Let me just give everybody my sort of 30-second view of this. So if you're writing an agent or you're working with agents, now you don't have to worry about configuring all these different tools that you sort of want to use. If Dex already knows how to use the tool, then it's simply just one tool that you have to add to your agent, which is Dex. And Dex maintains a history of everything that it's doing, so it can be smarter, faster, and cheaper to use over time. That's what's got me sort of super excited about what you built. And one thing you had said to me the last time we had talked was that these models already know how to work with shell commands. Like that's inherently trained. And so building a tool, the model doesn't know anything about it. We've got to really teach it. But how to execute shell commands, it already has some general knowledge about that. So, however, you still have to feed the context window with this information. You've handled all of that. So I'm really excited. And I've been playing with building some, fun agents. And so I want to see if I could get Dex to work with some of the toy agents that I've been playing with. That's something I'd like to see if we could hack on. But definitely give everybody a quick sort of demo.
Awesome.
And then we'll figure out how to install it on my machine.
Excellent. I'm going to give a quick demo. The one thing that we're doing, Bill, is we are running a security audit before I launch it. So what I'll do is I'll share Dex with you as soon as we get that done. Otherwise, my security guys are going to cry wolf. I'm going to share it very shortly. You'll be the first to get it, and your community as well. But let me start by installing it. Dex, you'll install Dex using curl. It's as simple as that. You'll have a brew kit, you'll have a curl, you'll have a cargo, because Dex is built using Rust. We'll of course have another session where I'm going to go into the weeds of the architecture of Dex. The first command I'm going to install is Dex bootstrap install, because I asked myself if value should be self-identified. In less than 30 seconds, someone should be able to install Dex, interact, and ascertain value. So the first command is Dex bootstrap install. And if you notice, when I executed this command, it pre-installed a set of packages, which is what I call as browser interfaces for browser use, like Playwright and Chrome. I pre-install a bunch of adapters like GitHub, Gmail, Google Docs, Calendar, Google Sheets, etc. and I pre-install a series of skills, things that I use every day, things that my team uses every day. And in the future, we're going to have these skills packaged into Dex Hub, just like GitHub. So you have semantics, push and pull semantics, where you can extract these skills, put these skills to use. When you install these skills or these services, each of these services need tokens. So what I'm going to do is pick up another screen, add these tokens for the sake of security. I'm going to say no, but if you say yes, it is going to redirect you to that page to set to install or provision these tokens, so that at the onset you'll be able to interact with these services. So for the time being, I'm just going to say no. I'll switch my screen to another terminal. Just give me a moment. And each of these tokens in the first version of Dex is going to be stored securely within a Dex vault. But in the future, what I'm going to do is enable Dex to use Keyring or HashiCorp Vault or any of these existing systems that already are more effective than Dex Vault. I'm going to show you that shortly in a moment. Dex token set. Now I provisioned a bunch of tokens on the other side. So when I issue the command dex token list, you'll notice I just created a series of tokens. And all the commands are mostly inspired by Git. If you notice these dex commands, every time you type a command, it provides a description and a help set command with examples. And I built Dex with somewhat of a precondition that what if in the future tools are going to be used by agents and not humans? So if tools are going to be used by agents, you got to make sure that tools have self-identification, self-description, and steering. These are very important. So suppose an agent is exploring and it issues a command dex token. It should be able to process this and understand what it means. So coming back to what Bill had initially said, that models are good at reasoning by analogy. So what I effectively did here is, instead of creating a docs page separately, Dex is self-documented. So when you type the command dex start, notice it explains to the agent what it needs to do to understand Dex. You have the mandatory agent protocol, where suppose a skill has been crystallized. For example, yesterday I asked through an agent via Dex, go fetch my recent emails. What Dex is going to do is start the exploration process, observe the agent, and then export this as a skill. And when it exports it, it indexes the skill so it can be searched for. So every agent is steered saying, before you start, always check if a skill or a flow already exists. If it exists, execute it immediately and bypass or sidestep splurging your tokens. If it is not, and if you're using Dex commands, you got to read the Dex grammar. And then from there on, how you orient yourself to use Dex. So this it's self-documenting, because it's literally telling the agent, use Dex, but before you do, read this. And after you do, you're fully acquainted and you fully understand how to use Dex. The other thing is, agents have a tendency to always reach out for JQ, grep, awk, And what I'm saying in my documentation is you don't need to, because I've taken some of the best parts of these and implemented by first principles inside of Dex. You can navigate JSON and query JSON using Dex filtering. You can search lines using Dex grep. So I was inspired, like I said at the onset, by these tools. So of course, these tools have been existent for a long, long time. I haven't fully implemented these, but I've taken the best parts by observing agents communicate and use certain aspects of these tools. So there are many commands as such. There is Dex grammar. The grammar is an unfettered list of things or commands that are available in Dex. For example, I could do a Dex grammar query, and it provides lots of information on how to use Dex to conduct filtration using regex, maps using transformation. So think of this as a language. I've essentially built an abstract syntax tree of a minimal language that is good enough and effective enough for agents to leverage when they communicate with services via MCP.
All right, so let's do it. You kind of built a DSL that Dex understands and can execute.
Pretty
All
much.
right,
Pretty
this
much.
is what I'd love to do, because we got about an hour left, and I really want to get to sort of playing with this.
So you have Dex inventory. Dex inventory gives you a list of MCP adapters that I have provisioned and bootstrapped into the system. This is batteries included. You get browser use with it as well. Now, if you want to create your own inventory, all you have to do now, suppose you have your own API. I'm going to use Quiet, my previous company, as an example out here. Quiet subscribes to Open API. They have their spec, which is available on their website. So I'm just going to issue one command. I'd say Dex adapter new Quiet, and I point to the URI of Quiet. Now notice it says it analyzed, it identified 120 operations, and out of this 120, it's categorized it into 24 tool sets. I'll come to the concept of tool sets shortly. It detected a base URL to communicate with. So I'd say, yes, I'm going to accept that. And it needs an environment variable, of course. So I have to provision that token because tokens are rotated. So I'd say Quiet API token. And it detected an authentication scheme because as it read the specification, there are different authentication schemes. You could have API keys, XAPI keys, basic authentication, and better authentication. Notice you don't have to go and identify in the spec because that detected thing out here is a hint to say, pick this. So I'm going to pick bearer tokens because it detected it. I don't need additional headers. I need JSON.
I can't see the bottom of your screen for some reason. I don't know if it's me or.
Can you?
I don't know if that's me, Kevin.
1 second.
It's almost like I.
That's fine because the orientation is there. Can you see it now?
I don't know why. It could be me. I screwed something up, but it's okay.
That's no problem. There's nothing below there, Bill. So very quickly, if you see tool sets out here, what Dex is doing is protocol mapping. It's identifying all endpoints in the Open API specification, categorizing them by tool sets, and providing optionality for you to pick what you want to choose to expose to the agent. Now, you might say, I don't want to expose all the APIs. I want to only expose scans, autofix, findings, and users. So you only pick these, you leave the rest, and that's it. That's it. In less than 10 seconds, you have an adapter that is provisioned. An adapter that can enable an agent through Dex to communicate with your Open API endpoint. I'm not saying that you do not need a MCP infrastructure anymore, but I'm also saying you do not need an MCP infrastructure anymore. You don't need this because you just adapt at no cost. Of course, when you go to write your MCP server from scratch to represent your brand new service, you might need your MCP infrastructure. But for now, adapters was something I built to scratch my own itch. I wanted something simple enough to communicate without paying a toll fee. So now we got this out of the way. We got skills, and I'm going to give you a flavor before I use the agent to interact of how the interaction plays out internally. Dex has many commands to start with, right? We spoke of skills that are already packaged. Typically, when agents start, they are steered or instructed to search. So suppose I say fetch emails, the agent's exactly going to do this. Dex flow search emails. Now notice it returned a match. And the match is it identified an existing skill that I provisioned, fetch recent emails, and it accepts two parameters, max results and time filter, and it gives examples of how to invoke that skill. So every such skill is indexed in the system, and it's made retrievable through search. So as soon as you drop an adapter, you use the adapter to explore, it becomes a skill, the skill is indexed, and now the skill is nothing but a shell script that can be run and you will get your results. You can use it with the agent or without the agent, but now you get determinism in the sequence of operations that is used to invoke the skill. So
All
let
right,
me
look,
shift.
let me. I'm gonna interrupt you for a second because you've thrown
Sure.
an hour at us, and there's a lot here. I want to hack on this thing, Chen. I want to hack on this thing. Is there a way for me to install this thing on my machine and we can sort of play with it? Or right now,
In the next session, because we are still provisioning an endpoint and such, if I short circuit any of those processes, it might not work on your machine. We're still going through a bunch of QA at the moment, Bill. So in our next meeting, I'm going to observe you do the hacking. So allow me maybe a few more days because we are almost there.
So let me show you what I have so you can understand where I'm trying to go. And then you
Okay.
could tell me if I could integrate Dex in this case. Okay. So
Sure.
because maybe I can, and I'm thinking about this in a completely wrong way here. So yeah.
Go ahead. Complete your
Yeah.
thought.
So let me show you something that I have, and I'm excited about Dex related to this project because I think if we can integrate it into this, it just opens up a world of possibilities. I just want to really make sure that it can. Because I'm not excited about MCP. I'm not excited about MCP integrations. I'm not excited about any of that. If I can have one tool that can do all of it, I'm excited about that. I only have to do one integration, basically, and configure that integration. So I have been, I haven't slept in the last like several weeks because Ron Evans started this project called Yzma.
Mm-hmm.
What Yzma is essentially non-CGO Go access to the Llama CPP APIs. He's basically mapped them all using two other packages that allow him to access these C APIs without needing CGO, which is just mind blowing. Ron Evans is like just I just bow every time I see him. And he's
Awesome.
just released today as his beta 3, so it's really stabilizing. So what I think of Yzma as my Go Llama CPP API. Okay. However, it's a low level API. So what I haven't slept for the last, I don't even know how many weeks, is working here on Kronk. And if you know anything about the Emperor's New Groove, Yzma was like the character that's the queen, like in charge of everything. Kronk was that character's sort of minion or servant. Okay. So
And Kronk is your project, isn't it?
yes,
Bill?
Kronk is my
Okay,
project.
awesome.
Yeah.
Got
So
it.
we even got a little gopher that looks like Kronk. So
Wow, that's awesome.
the idea of Kronk is to build on top of Yzma an OpenAI sort of compatible API for this stuff. So if you're already used to working with HTTP calls to, say, an OpenAI server or an Olama server, then this API is going to feel really familiar because I've basically built it in API form. My next step after this is to basically rewrite an Olama server in this. So it has the REST APIs that Olama already has. The advantage here is Olama can't keep up with the latest versions of Olama CPP. This can because of Yzma. Now, so and I've got a bunch of examples here, but we're going to play with on the AI training repo one of these projects, which kind of acts like an agent already. So
I see.
and I have tool call support working in both GPT and non-GPT models. The GPT was unbelievable, but we got it working. So
Awesome.
it's essentially what I'm going to do. I want to show you. And the whole point about Kronk is I run the model. I can load my own model files locally. I don't need a model server. I don't need Olama started. I don't need anything, right? We're running the models locally. So I'm going to play with the GPT OSS 20B model. That
Okay.
model you're going to see is right here. We've already, right? Well, it's already downloaded. We're going to play with this.
Nice.
We'll be working with the latest Llama CPP APIs. And essentially what this code's going to do is go into a message loop where I can ask a question. We'll add that question to a list of chat history. Okay. You and I are going to play with this part. If you've ever played with OpenAI, this already looks familiar, right?
Yes. Yes.
So we're going to give it a set of tools. I can set all my tokens and all that stuff. Perform a chat and then get the response back all streaming. Right now, the only tool that I'm playing with, if it's a GPT model, that's the tool structure. If it's not, this is the tool structure. And I'm just pretending there's a get weather tool. We're going to turn this into
Got it.
Dex very soon, okay?
Awesome.
And so
Awesome.
if I run this real quick, AI training, and anybody can clone this and run it. Example 13, step 1. And these examples are in the Kronk repo too, but I want to hack on them over here. It also goes, every time it runs, it will see if there's a new version of Llama CPP.
Yes.
They must release a new version 4 or 5 times a day. So we're constantly making sure that we're working with the latest. Okay, so
Awesome.
I've got this thing. I can say hello model. And I'm now talking to my locally, model right here, okay? And then I can say, and you can see the reasoning is in red there. What is the weather in New York City? And you can see I've parsed out the tool call that I gave it. Another thing I want to just do before we start hacking. This is the usage information that Kronk sort of provides you as well, so you can see it. When you get the last, come on. Sometimes this agent is. I'm spending more time fighting it than I'm getting help from it.
Is that VS Code or IntelliJ?
This is VS Code using SourceGraph AMP, which is what I love.
I see. I see.
Now, one of the things I did also with Kronk to help debug is when you get the last response back, I give you the prompt. And this is all already, these data structures are already OpenAI sort of tuned, like compatible. But let's just look at the prompt too, just so we can see, because this is going to be important when we're playing with Dex. So if I say hello model, okay, so this is the prompt that we created based on me saying hello model.
Okay.
And this is the tools, the functions that were put together by the GPT model. I have a Jinja template that works here with that.
I see.
Okay.
I see.
So what my brain says is I want to add a tool for DEX. I just want to see this show up right now. So even if I don't have DEX installed, okay?
You can just, what you do is you add curl as a tool. You can just instruct to steer the agent to use curl on your computer use and see whether it picks it up, right? And what it's
So
effectively
let's do
doing
that.
is you say, yeah.
Let's do that, right? So this is the get tool here. Here. So some function, we're going to say it's called curl. I don't know. And say curl can be used to make HTTP requests. And then there's a parameter called URL, and URL is required, right?
Yes.
So I can specify at least this right now. Now it's going to treat it as a function, which is fine, but I can convert that back into a CLI tool, at least for this, for what I have right now, right?
Mm-hmm.
But what you're saying is it should already know how to use curl already. I don't need to. I think what you're trying to say is I don't need to add a tool. It should
Exactly.
already know how to use curl, right? So why don't we
Exactly.
try
See,
that? Yeah, why don't we try that for a second? All right, so this is the 20B. I can already run it here. Okay. So what would I ask it? I don't want to ask it specifically to use curl, but
I'm trying to figure out the right API, because here's what I'm thinking.
curl
What you can do is define, yeah, there is a particular service called as WTTR. I'm trying to find a way to send it to you on email. Just give me 1 second. You could just say api.openweathermap and you just accept the country as the input, and then it just produces the output on the other side. So
but not
that
adding a tool.
it's not a tool. That you're literally, what you're doing is you're creating a tool definition. The tool definition is essentially containing the curl to the endpoint, and you are just substituting or parameterizing the country. So you say, what is the weather in London? And the agent should be smart enough to take London, substitute or parameterize it to your tool call,
Well,
and then
it's
just
doing
invoke
that
that.
now, right? Like,
It's doing that now? Okay.
yeah. Look, what is the weather in New York City? And you can see here, I've already parsed it out, but it
Oh,
already
got it.
told me,
Got it.
right? Do this.
Got
So
it.
what I'm saying is I wanted to add, the idea was to add a tool, right? Oops, sorry.
Now, you can add another tool to try to do the same thing. I'm just trying to figure out how to do it.
And I don't care if it comes back in a function form, like I can convert that into a, right? So, so I'll call curl, right?
Okay, perfect.
And then I can say, use this to allow us to download, I don't know. And I can just say, give me a URL, right? Just to keep it simple.
Exactly.
So I'll add this tool. Let's go back here, run this again. And I can even be specific here. I may not know this structure, but let's just say, let's make it simple for it first. So I need to, can you download this GGEUF file? Okay, so look, so it was smart enough to say call curl with that URL, right? This is what the prompt looks like now.
That's
That's
awesome.
beautiful,
That's
right?
awesome.
Like that's beautiful. This is all thanks to the Kronk project and
Uh,
support. So my
can you
idea is,
can you take me
uh,
to the tool definition, Bill? I just want to look at your tool definition. Okay, perfect. So you have type
this is the
function.
GPT definition structure.
I see. The one thing you can try progressively, Bill, I don't think we can do it immediately, is get a chance, right? Read this paper by Microsoft called as tool space interference. 3 words, tool space interference. And they have a very interesting hypothesis or conjecture where they say sometimes the agents get confused when you have 2 different types of tools for the same thing. Example, you have GitHub MCP and you have your Git on the command line. So when you say fetch issues, the definitions of the MCP server and your command line are somewhat the same. But in reality, your command line is more effective than the MCP server because the command line is already authenticated. It with GitHub, it is faster. It has low latency. So they say when your definitions are somewhat close to each other, the model sometimes gets confused of what to pick. So that's something we can try.
But let me ask you then, like for me to use Dex, the idea isn't that I'm going to be adding a tool, right? Because look, let's
Pretty
get rid of
much.
this tool. Let me
Yeah.
get rid of this tool for a second, right?
Yeah. Yeah.
And let's just say I ask it the same sort of question. Now, this model doesn't have a tool for that, but it's given me these options, right? But it's not sort of that's the prompt. But it's not
Um,
like, so what if I said, and just give me a single tool call? And I could give it JSON, right? I could tell it, give it to me in JSON. So you're right here that even though it didn't listen to me very well, let me do it again. Okay. Provide me a curl call to download this URL. Only provide the curl call and nothing else. Oops. Shit. I just screwed that up. Sorry.
that's okay.
But it did it actually. Look, it gave that to me, right?
Yes.
And if I told
I
it to
can
do it in JSON, it would have been even better, right?
exactly. I'll sort of give you an example. Like if you unshare your screen, right? I'll show you how the agentic reasoning loop works, and then we can come back to your dashboard and reason. So let me try this very quickly.
I think, did you stop sharing your screen?
Yes, I stopped sharing. Oh, I
All
can.
right.
I was wondering whether can I share it, and we can share it, right? And we can see each other's screen.
Share your screen again, and then I'll make it go
Okay.
live.
So I shared my entire screen. Do you see my screen now?
I see it. So I think your screen's
Okay.
being
Yeah,
shown.
it's a it's a workspace. So I have a cursor workspace right now. Can you see my screen?
Yeah, I see it. Nobody else is telling me
Okay,
that they can't see it. So
excellent. So if you notice, Bill, at the onset, right, I'm asking the agent to execute deck start, follow every rules of the guidance protocols, execute deck grammar, and get familiar with it. It's almost like I don't have to say this whole thing, but I usually say it. I'm further fine tuning it. But if you notice, the agent is executing each command I instructed it to and
what
getting
program are
familiar.
you running right now?
I'm running Cursor with Composer One agent, their new agent.
Okay.
It's a Cursor IDE.
So this is a
Okay.
chat app for Cursor.
It's a chat app. It's a chat app. Okay. Now, I very
No,
quickly instructed. Yeah, go ahead. You had a
you
question?
said, yeah. Let me start from scratch here. So you're in a traditional chat app that is talking to a Cursor model,
This is what I
and
asked. I said,
this little app is running locally. It's not a browser.
yes. It's
Okay.
not a browser. It's an IDE. It's a Cursor IDE running locally. And I've instructed in the chat box, I've instructed the agent. It's using a composer model. There are many models. I've chosen composer. I can keep switching. I said, execute deck start. I'm telling the agent, execute this command because you have access to my terminal. Get familiar with this command. So the agent went on its excavation, understood, and it's summarized saying, I get it now. I know how to use it.
Okay.
Now
Question.
notice,
Wait.
yes,
Slow
please.
slow down. Slow down. Slow down. So this app took the output, put it back into the message structure, and then fed it back to the agent essentially.
Pretty much. If you're using cursor like VS Code, right? For example, when you start, you click the plus, you have the chat interface. Suppose you're writing code on this side. I don't have any code. It's just an empty project.
Oh, this is their
And then you have,
IDE. I see.
this
Okay.
is an IDE. It's just an IDE.
Okay.
I don't have anything on the other side because
Okay.
I'm just kind of showing how to use Dex. I don't need code.
Okay. So this agent already knows when it ran the command how to
Ex-
feed
ex-
the standard out
exactly.
back to it.
Exactly.
Okay,
Exactly.
that's fair.
Okay. Now, by executing this, I've helped the agent familiarize itself with Dex. And now I'm going to jump straight into my set of requests. I'm going to say fetch or retrieve my recent 10 emails.
So I want to
Right.
when I'm allowed to install Dex, I want this
Sure.
little app that I started. I'm going to build a Dex version. My thing should be able to
Exactly.
do the same exact thing. Execute Dex without
Exactly.
having to add a tool. That's the whole point. I don't want
Exactly.
to have to add a tool. It should know how to
Exactly.
do that. Okay.
Exactly. Exactly. You can add adapters and just go to town. But now I'm going to, if you notice, my question is retrieve my recent 10 emails I received today. Now, observe the reasoning loop that plays out, right? It first searches for emails. It identified a script because I keep executing it every 10 seconds. And boom, in less than a few milliseconds, all my emails are summarized. No
Okay.
reasoning.
Scroll back up for a second. So
Let's walk through it one by one.
it has all that already in the context window, thanks to the first command. Now you
Yeah.
said receive. So this agent went ahead based on what it already knew
hmm
and went ahead and executed deck flow search recent emails.
And then it figured out that I have a skill because I execute my email check every day. The agent through Dex figured out instead of keep repeating this thing, it crystallized the skill. I'll come to that later. This is another long conversation we need to have, but the concept of a skill is the agent observes behavior. It learns how to effectively execute a series of commands to fetch the email. It persists or stores that as memory, and now it just rapidly just looked up that memory and executed. It
I
bypassed the
wonder,
context window in time.
without this being, see, I'm just going to get technical here. It's interesting to
Sure.
me that these agents, and I see this with SourceGraph AMP, right? Maybe I need to bring those
Mhm.
guys back on. Without defining the tool, the model produced some output that was good enough for this agent to then execute and go back into this sort of loop. But I had to return
Yeah.
some structured. It's interesting to me. I guess that's what these
And
agents are sophisticated enough to do.
yeah, they're good. This is how I define it, Bill. There's a concept of perception and action. Perception is the agent reasoning which is really good at what you just showed in that reasoning loops that you are conducting. The agents are really getting smart at that because of the various frameworks that have been built, the model becoming significantly more effective in terms of enabling reasoning. DeepSeek essentially incepted that. So you leave perception to the agent, and what you do is you start memorizing action. You start caching these actions, things that you repeat, so that you don't have to unnecessarily waste context window. That's what I did with Dex. I optimized action. I leave the perception to the agent.
I just
So
find it interesting that it can. I almost
um,
wonder if
I-
they have a generic tool that just returns structured data back.
um, it does return such structured data back, right? What I do with Dex is, I'm clicking out here. If you notice, Dex is nothing but when it crystallizes skills, it creates a shell script. In the shell script, I have a command called as Dex display. And with Dex display, I'm displaying the from subject date to and a snippet of the email. And all the agent is doing is picking those and summarizing it here.
Well, I understand that piece. What's really interesting to me, if you scroll up, because that's the final content to summarize. Like, I get that. But the fact that you didn't define a tool, no, go up where it said I need to execute a.
One second.
Yeah,
Yeah,
here.
you go.
Right.
Yeah. It's
So
searched.
this is interesting to me because it auto ran this command, right? Which
Yes.
means to
Yes.
me that somehow this model's prompt has something in it that tells it, if you believe that we should execute a CLI tool, right, return it in some
Let's do.
structured way.
See, the next time we hack together, right? What if I tell you I can entirely eliminate that tool definitions that you have? You're just going
That's
to
what I
have
want to
one tool
see.
definition. Yeah. You're just going to have one tool definition that says this: execute deck start, follow rules, understand guidance. That's it.
Okay,
And
yeah,
the
right. I need a
discovery,
tool definition for that, right? But I just need one.
exactly.
Okay,
Now
that's
let's go.
that's what I'm excited about.
Let's go a bit crazy. Okay, I'm going to walk through many workflows and connect them. Now, this is the things that I do usually when I get lost. I'm trying to find a library. I say search repos for um, Rust sandboxing. So now it's going to invoke another tool, which is Git adapter, identify a skill that I had in the past for search before I even type the results are here. Less than 5 seconds. So it identified Lucet, KCL, Quasar. Okay, Quasar is fairly, let me try this, Nix. So this is fairly interesting in the Nix community. So I'm going to ask another question. I'd say, by the way, all of this is the agent is only using Dex, not touching any other tool. So the next thing I say is retrieve the top committers of Nix Nazareth. It identified another skill. I got the top committers. So these guys are fairly, and Matea is fairly interesting. So note now, I'm going to say extract profile information, email, LinkedIn, website, X handle of Nazareth, and Matea using headed playwright via Dex. Now notice this bell. I'm stepping out of the screen. Dex is going to enable the agent to use the browser, discover this individual, and extract their profile information. And this is the discovery process. This is Dex doing it. I stepped off the screen. I am not touching the keyboard. It popped the browser, which is Playwright, or it can use Chrome DevTools headed to because that is packaged.
So
And it's doing Yeah, go ahead.
I just ran an experiment that sets us up. So I first of all, this is amazing, dude. I want to play with this so bad on my little agent. When I can download Dex, you have to let me know.
I'm going to
But
give it to you before anyone else because
yeah,
love to seek feedback, and then we'll do an online training process as well.
but let me show you something I just did while you were doing that. I added this new tool. It says invoke CLI command. Use this anytime you need to run a CLI command of any kind, and then just give me a set of arguments, right? So, oops, sorry. So I just said, can you download this file, please? And look what it gave me in a structured form. Like, this is beautiful, right?
Yeah.
Curl, and then everything I needed to do that. Like, I could just take that and be done.
I mean, to your point, right? Agents with large language models have become smarter with structured output. You don't have in the past, we had to prompt to receive structured output. Many of the models have gotten more and more effective with this. So the reasoning has gotten effective, structured outputs have gotten effective. Where the gaps now are is how do you effectively bootstrap the system with many, many, many such tools? So you become hyper productive. You're only talking to the world through agents.
So let me ask you this. Now I have this now, right? So your CLI tool, Dex, can feed the model a bunch of information, which is beautiful, right? As part of a message structure, or even as a system prompt, I would imagine, right?
Mm-hmm.
So again, if I wanted to hack on this for a second, go into the main loop real quick, okay? Even before we get to this, let's say that I want to add a message to this thing. I want to add a message to this. Well, brain is shutting down here, but hold on. That's just messages. Okay, that's fine. Messages. Here's my idea. Okay. What I want to do is, okay, just a tiny hack, right? Like, I'm imagining that I'm going to use your CLI tool that can do anything that would be possible on the command line, right? Like, I'm imagining that you're going to feed me all of this content about what Dex is. And then I've got that tool, that CLI command tool or Dex tool, and it should constantly invoke that, right?
Yes.
In a way. Okay. So this is what I
Yes.
want. Okay. So this is why I need Dex, because I want to do that, right? I want to call Dex, add that into the message history, and have just
Yes.
one tool here, right? For everything,
Yes.
including get weather.
Pretty
That's what I
much.
want to play with.
Pretty much.
Yeah. I'm excited
And
to make that work at this small level.
and Bill, this is how it works, right? If I pull it all together, there's a concept in the world of Dex. There are two concepts. One is an adapter. You adapt, you point to an old API. When I use the word old, I mean REST, GraphQL, Open API specification. You create an adapter module. And once you drop that adapter module, the first time you interact with that system, say, for example, Ardan Labs has an Open API specification. You drop that module, you start interacting. It observes your interaction. When I use the word it's Dex observes the interaction and crystallizes those as skills. You might say, fetch billing information from Ardan Labs, fetch the current schedule from Ardan Labs. Now it crystallizes or stores those skills on your computer in the .dex environment folder, similar to .git that is associated with every project. Every time the agent now, you might ask your agent a question saying, what fetch my recent bills that I received today or payables I received today. It says, hey, you did the same thing yesterday. I'm going to go invoke that skill, and it'll invoke that skill. So now what you're getting is instantaneous deterministic answers, of course, with different data, refresh data, without splurging context, without splurging tokens in the context window. So that's the fundamental thing, and we'll go through that process. What I will do is in the next meeting, right? I will give Dex to you. You hack on it. We're going to drop, fail, figure out how to actually get the thing going with your. I love your two projects that you're working with, because that unleashes something more, even more interesting, which is running in locality space, where you're working with a commodity model, the llama. You have an agentic loop that you have constructed, which is simple and elegant. And then you're hooking Dex with adapters. So it becomes very self-contained.
It is. I'm already running in a sandbox in a sense because
Yeah,
it's my machine. It's all local.
exactly.
I'm not paying anybody anything to do this, right?
Exactly.
I'm just paying for my own hardware. And then I get the full power of what the models could do because Dex is giving it the full tool set that it needs. That's why I'm so excited, because my idea now is I've got the Cronk API working I'm really happy with where it's at. It's very,
Awesome.
but, and I don't know if I'm going to go to a 1.0 just yet, but the next step again is to build a new Olama on this because I just for chat complete. But think about how I could publish a model server
Yeah.
with Dex already integrated in it.
Yeah. Yeah.
It would be one of the most powerful Go-based model servers out there, right?
Absolutely.
And
Absolutely.
it would basically, from a functionality perspective, surpass what Olam is at right now, because
Exactly.
they just don't have that next level execution engine that you would provide. It's like mind blowing to me. If I can integrate the ISMA, which I've done here, and then Dex, and then, dude, it's just mind blowing to me what we could do with this.
Absolutely. I mean, to your point, right? We will, the future, the way the future is shaping up. We as humans will interact with our services with agents as conduits. We will have agents as the interface, which is proxying to the world on our behalf. And I feel that is a very compelling future to look forward to. And, fortunately, most of these frontier model companies and variety of companies are optimizing around that. And that would make us more productive rather than, I would say more lazy at this point. But interesting world. And I'm happy to kind of hack with you on that, in the next iteration.
Yeah, I definitely want to hack on that because my whole stick right now, my whole thing, what I care about the most sort of is having the ability to run everything locally. Like not to be, I want to see if the other model does this. Not to be, I don't know if that supports required, honestly. Not to be having to pay for everything all the time. And I know the open source models are not at a point where you can really use them for my agent, right? Like you need more powerful. But I think over time, what's going to happen is the open source models are going to get to a point where they're going to be good enough. They're never going to be what's out there, right? In Gemini world and stuff. But
Exactly.
they're going to be good enough. And that's when it gets super interesting to me, this sort of technology. Because one of the other things I'm going to do is bundle up single Go programs that
Mhm.
have its own model, runs its own inference, right? I don't need install anything else. And also has contained in it, it's basically a RAG service with my book, with all my videos, but individual services specific to one content. I'm using DuckDB as a vector database that can run also in process. So I'm not going to deploy a vector database anymore. I'm not going to deploy a model. I'm not going to pay anybody for any of this stuff. I'm going to go into cloud or get a simple VM, honestly, deploy a single Go service. It downloads this Llama CPP libraries, downloads the model, and just serves up a chat that is like amazing. But now if I add Dex to it, it can just do anything. That's
Absolutely.
just mind blowing to me. Like I want to see that happen.
And can you, Bill, can you drop your links for those, both the projects you mentioned? I'd love
Oh
to,
yeah, let me do that.
yeah.
I'm curious if this
Kronk
other.
and the other one.
Yeah, let me do that now. Okay, so this is Kronk. I don't know if you have access to this. I'm gonna put it on here, and I'll send you an email with these two if you're not able to
Kronk
get them.
Bill Kennedy. I got it over. Yeah, I just Googled on it. So
See, even the other model did it perfectly, right? Like
exactly.
that to me gives me hope that I can integrate Dex at this level. Once we learn how to feed the rest of the model your content, which to me was brilliant. Let the CLI tool feed the model, right? Feed the context window what we need. So now when I ask this question, this won't say curl, it will say Dex.
Exactly.
Yeah, it's going to be wild. Wild, 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 wild. So this is kind of
And
cool. I added, yeah.
Ron Evans is a part of Ardan Labs, or I should look it up.
No, no,
It's
no,
quite
no, no. He's
interesting.
just a good
Okay.
friend. He has his own company called Hybrid
I see.
Group,
I
who's
see.
been, Ron is a low level, like all his projects are hardware related, right? So he's
I see.
done, he's had to play with Seago his whole life to do fly drones and to do vision and all this stuff. And now he wanted to play with model stuff in integrating this stuff. And he realized that Seago wasn't going to cut it this time because the project's moving too fast and there's too many things. So he just mapped the API calls sort of directly. What
I
Zima
see.
also is doing, which is really interesting, which is great because it happened to us last night. They changed how they're distributing the C libraries. They added concepts around symlinks and stuff. It broke everything. Ron didn't sleep for God knows how many hours this morning fixing it. But he knew that everything was broken when he woke up because he's got actions that he built here, Linux, Mac, and Windows. And he's also integrated into the Llama CPP project. So when that changes, boom, he's doing a build. We know immediately if something broke. And
I
he's
see.
like on top of it. So we're always running the latest stuff. It's just mind blowing what Ron's done.
Awesome.
But because of Ron, we can now write code that I've shown you, that looks like. I'm going to leave that in there for next time. So, okay. So
Awesome.
so the next time, the
Yeah.
moment Dex is available,
Yes.
for me to download, you tell me. I'm going to download it, and then we're going to get back on here and hack on that. Now, all
Awesome.
that code that I shared with you, in that, here's the other repo with the AI stuff in it. Hold on. Ardan AI. I have the examples in Kronk, but I'll always play with this example 13 step 1. Hold on. That's an example 13 step 1 is what I was just hacking on. once you can already start hacking on this a little bit and see sort of what you can do with any of those two models. That would
Got it.
be, but I love hacking. Unprepared hacking to me is my is my favorite way to go.
Nice.
So,
Awesome, awesome. This is the AI training, right? Okay, I'll look at
yeah,
this.
I'm just gonna push up
Love
the
model.
change I just made there, so we have that command. But ideally, you want it to always choose Dex because then there's security behind that as opposed to just any sort of CLI call. So,
Exactly.
Okay, so
Perfect.
yeah, I've just
Awesome.
pushed that up. So we now have that. So for anybody that's watching this, Dex to me is going to be it's what's going to allow a project like Kronk and others to be able to move very quickly in terms of supporting tooling without all this need of building MCP servers and all the tool sets and minimizing context windows. And the moment you showed that to me, my brain just went, yes, this is what we need. Like, this is going to be, everybody's going to, I mean, there'll be MCP servers out there that Dex will talk to because people will build out tooling. And I think there's a place for MCP. Don't get me wrong. I don't think it's going away. I just don't think the agent is making the call directly. I think they're making those calls through something like Dex, right?
Got it.
Let Dex have that knowledge base on how to talk to MCP. I don't need to know how to talk MCP. All I need to know is how to tell Dex to do it. And that
Yeah, absolutely. Well
simplifies,
said.
right? That simplifies the Kronk, what we're going to build soon, right? The Olama, the next Olama, which will be Kronk, sitting on that. So, dude, super excited
Awesome, Bill.
about what you've done. So let
Awesome,
me
Bill.
know.
So,
Over
yeah,
Christmas, definitely want to hack on it. You've got those programs there too. So
sure.
I'm
Uh,
really happy that you jumped on today, man.
Definitely. It's always a pleasure, Bill. And I'm looking forward to the next time because, I want to observe how you stitch things together because that's the creativity of connecting these multiple things together, making, I would say extracting value. So look forward to it. Thank you, Bill, for having me and, enjoy December and talk to you
Yeah,
soon.
no, yeah. Thanks, man.
Take it easy.
Okay, so sweet. All right, so hopefully you've learned a little bit more about Dex, and I think its importance in this ecosystem. I got to show off a little bit of Kronk. We added a couple of tools over there, so we have CLI sort of support, but eventually that will be Dex. Um, and I think Kronk is pretty stable now in terms of AI. I'm gonna still wait till the end of the year before I put a release 1.0 on that. Um, and there's just a few more things I want to do there. But next step is to rewrite or to build a Olama Lite sort of version using Kronk in this project, where you can just sort of do that. And my goal is if I can get Open Web UI to talk to the Kronk service successfully for chat completions, like we're basically there. So we'll see where it goes. Anyway, appreciate everybody being here, and we'll see if I'm here on Thursday. I got to look at my schedule, but I plan to be here Thursday, so we should be able to do a 2-hour show on Thursday. Maybe we'll work on the Kronk service together on the show. That would be kind of fun. All right, bye.